Alright, this is a quick introduction to show you what you can expect from watching the end of this video. So we have our crosshair in the middle, and it scales based upon our velocity. So as I go slower, it decreases. As I speed up, it increases. And on top of that, we go a little bit step farther. We give ourselves the ability to control basically everything we can need, so we can see everything on the fly and tweak it as such. So basically a higher max velocity means we need a bigger velocity in order to reach the max amount. And then once we have that, we can increase the total size of the offset that we want the crosshair to spread. And then we can also control, if we decide to set it up automatically to update, how many times per second that this is going to update. So just so you don't have to do it on every tick if you don't want to. You can just simply set how many times per second do you want this crosshair to scale. So that's what you can expect. Alright, so I've been working on a inventory for about 2 weeks straight now, so I want to branch off into something else as I need just a break from it. And I'm going to give a shot at making a dynamic crosshair. So this is going to be the first one I've ever made. Haven't done a whole lot of research on it, but it's a simple enough thing where it honestly shouldn't be that difficult. But basically, I want my crosshair to look kind of like my mouse cursor right here, and then this will be when I'm not moving. Then when I start moving, I want this to open up, so the top, bottom, left, and right start to open up and spread apart from each other based upon how fast I'm moving. So the faster I move, the more they spread apart, so on and so on. So kind of like the default crosshairs in like Valorant and CSGO and that kind of thing. And I also want to make this so it is fast and efficient. So that was my first idea of using actually slate to draw this. So it would be a user widget, and I would just be using slate brushes to draw it. So that way people had a decent bit of customization over it, but not enough, in my opinion, to make it where it's worth using drawing the lines manually. So instead, I'm going to use size boxes instead, and then people can put whatever they want in those size boxes and change their size however they want, and it'll all work the same. So we're going to start by making the class. So this is my class right here. It's just a user widget. It's nothing fancy at all. And we know that we need 4 size boxes. So I'm going to go ahead and forward declare size box, use size box, and put those in a protected section. So we need 4 size boxes. We have to be able to bind them inside of the editor. So we're going to give it the meta of bind widget. So uProperty, and we'll do blueprint read only in case we want to read it, and give it the meta of bind widget. And then we're going to do size box underscore top. Now we're going to do the bottom, left, and right, and rename them. So SB underscore bottom, SB underscore left, and SB underscore right. So there's our 4 size boxes. Now we want to have some properties that we can edit to see this, because this is going to be set up in a way where we can adjust it on the fly inside the editor and actually see the result. So that way we can have a very nice test environment to tweak the values how we want and just see the results instantly without having to play test each and every time. So we're not going to do that just yet. That's going to happen a little bit later in the video, but let's set up the properties first. So property, it's going to be I'm just going to do edit anywhere because I don't really care about it, and give it the category of FPS Template Crosshair. So this is just going to be float test velocity. So this is going to be like our pawn's velocity, just so we can tweak it and see the change on the fly. Then we want to have a max velocity. So the fastest that our pawn can move is basically what we're going to assign here. That's going to be what controls the maximum amount of the crosshair being open. And then I want to have, let's see, one more, and this one's going to be like our offset. So how far away can the elements, or like can all 4 of the spots with the crosshair move? So max offset. And that's really all we need in terms of variables. The only thing we want to have now is I'm going to expose this as a pin. So basically just get our owning pawn, so that way we can constantly check and see what that pawn's velocity is, so we can update our widget as we need to. So we're going to do a uProperty, and just in case, we'll just do blueprint read only so we can read it. And we want to give this one the meta of expose on spawn. So a pawn owning pawn. And I'm going to forward declare a pawn as well. So that'll actually make it as a separate pin when we go to create the widget. Just like if you were to check expose on spawn inside of one of the inside of Blueprint. It's basically the same thing. Okay, once we have this, we want to create a constructor. So we're going to make a public section. Create the constructor. It takes in an object initializer. So I'm just going to grab it out of the parent so I don't have to type it. Create the definition. And we have to call super and pass in the object initializer with it as well. That's just for widgets as far as I'm aware. So we want to set up test velocity, and max offset. So test velocity by default, it's going to be 0. Max velocity, I want to set to my max character speed currently, which is 350. So default, I think, is 600 with the mannequin. And max offset, we'll just give it a test value of 100 and see if we like that. Because we can, again, we'll be able to change these on the fly and see them update in real time just inside the editor. So once we have that, let's go ahead and set up all those size boxes. So I'm going to close down the editor and relaunch. Okay, once we're back in the editor, let's go ahead and create our widget here. So widget blueprint, w_crosshair. Open that on up. Go to the graph, class settings, and then we can change our parent class. We're going to set that to our crosshair widget. It's going to throw a fit because we need to create all the size boxes. So it's under panel, size box. We're going to anchor this one to the middle and reset its position. So this one would be like the top. So SB_top. And I want to adjust the size of this. So as well as I want to see it. So I'm going to grab an image and drag it onto it. And I'll just set the image to a red color. So we basically just got a red brush on it. And let's try to get a rough view of the size that this would be. Like this. So let's try to decrease the thickness. That is a really wide one. That's still way too thick. Try like 2. Okay, that's a little wide. Go a little bit less. So let's try like 15. I think that's pretty good there. All right, so we have our size. So we have our top one. Now we want to duplicate. So Control W, bottom, left, and right. Now we just got to rename these. So bottom, left, and right. Then we compile and save, and everything is gone. We're good to go. So now we just got to set up the offsets here. So basically all I'm doing for the top, I'm going to invert this. So the X is going to be 2, Y is going to be 15, so it's tall. Set the alignment to 0.5, so it's in the dead center. And then I'm going to bump this up to 1.1, so that way it's a little above center, and the center is slightly open. And exact same thing for the bottom, so 2, 15, 0.5, and 0, or negative 0.1, so it goes down a bit. Now for the left, I'm going to do the kind of the same thing but in reverse. So we're going to do negative because we're going to the left, 1.1, or sorry, positive 1.1. Got myself a little backwards, and then 0.5 on the Y, and then the right we can do negative 0.1 and 0.5 on the Y, and we now have our little crosshair. So now let's set that up really quick. Yep, so we're going to go ahead and create the widget. That connected anymore for this. So we're going to pass in w_crosshair. You can see we now have an owning pawn as the pin like we set up. So we can just pass in ourselves and add it to the viewport. Let's save everything and hit play. And there we go. So there's our current crosshair. Doesn't look too bad. Now we just want to make it so when we move, it expands, we stop, it goes back down to what we see now. So basically the default. So if I click on this w_crosshair here, you can actually see all the properties that we expose. So we can tweak these as we need, but we don't have a way to update them live. So we can really test it. And that's what we're going to set up now. So here's where I'm going to show you how to get a little bit fancy with your widgets. And honestly, it's really quite simple as well. So the one thing that we're going to want to set is basically going to be overriding a function called Synchronize Properties. And basically anytime you make a change, such as, let's say I take this and I set the test velocity to 2, it's going to call Synchronize Properties. And that's going to allow us to run code that will make the change for us visually. So we're going to override synchronize, I don't know how to spell synchronize properties. Create the definition, make sure you call it super. Does it do anything? Yes, it does. So make sure you call it super. And here we want to update the changes. So I want to have a function that we can update based upon our velocity. So what I'm going to do is have a public section, because I want this to be called from elsewhere as well, if wanted. And this one's going to be called void. Let's do handle crosshair scale, I guess. And then we're going to pass in float velocity. That way we can have it in one nice place. So from synchronize properties, all we're going to do is call handle crosshair scale and pass in our test velocity. And then here, this is where we actually do kind of all the work to make it, adjust visually. So basically what we're going to want to do is get our size boxes, and we have to be able to move them around. So we can't move them around directly, and I'll show you what I mean by that. But first, let's check and make sure our size boxes are, valid. So if you, what's it called? SB underscore top, we'll work with the top first. Make sure that's valid. Then we want to do some stuff. So I'm going to do the check. So SB top, SB underscore bottom, SB underscore left, and SB underscore right. So we have all of our size boxes. We're making sure they're all valid before we do anything. Now what we're going to do is offset, basically just move them around. So SB underscore top, if we search for location, nothing comes up. We search for position, nothing comes up. So how can we move these? Here's where you can kind of look and see. So if I click on this size box, we come over here, we have our alignment, we have our position, we have our size, we can tweak it how we want. And that's because it's in this slot. So we have this, our canvas panel slot right here. And I guess it would probably be a better idea if I actually made this inside of C++, so it has a canvas panel like guaranteed by default that they're all the child of. But for the time being, it's okay. But anyways, you have this canvas panel slot. So that slot is what contains all of the stuff that we want to tweak from it. So what if we do search for SB underscore top and search for slot, you can see that it's actually a value. So the parent slot of the U widget allows us to easily edit inline or edit the layout of that is controlling this widget. So in our case, it's going to be a canvas panel slot. So we want to get that. So that way, once we get the canvas panel slot, we can move them around freely. So if U canvas panel slot CPS underscore top equals, now we're going to have to cast to it. So if we look for SB underscore top and do slot, you can see slot returns a panel slot, if it'll show. Come on. Good grief, I'll just go to it. All right, fine. It's being a pain in the butt. There it goes. Why won't you show the type? There it goes. So you can see it's a U panel slot. So that's not what we want. We want basically a child of that. So cast to U canvas panel slot. And we just cast a slot to it. Like so. All right, what are you complaining about? No, so we have to include size box. So include components sizebox.h, and make sure you include components canvas panel slot as well. And now we're good to go. So here we can work on our offset. So we want to, once we have just the top done, we can easily do the other three very quickly. And then later on, once we get it working with velocity, we are going to cache all of these canvas panel slots. So we don't have to, actually really cast each and every time we want to run this. And so we can just check if make sure it's valid. If it is, we grab it and we're good to go. But now if we look at CPS top, we have set position and get position. So we can set its position. So it's an F vector 2D. So we have our X and Y. So F vector 2D I call it position, and we know we don't want it to move left or right. So position.x equals 0, and position.y, we want that to equal something. So we'll just set it to 10 for now, and pass in position. So here's where we want to do our little bit of math. So basically, we're going to take our test velocity, or well, our velocity, and we want to normalize that between 0 and our max velocity. So that way, if our velocity is, let me see, is 175, we know that the value of the result of the, normalized, the result that it gives us would be 0.5 because it's half of 350. And we would use that as a way to multiply between this offset. So we would take that normalized value and multiply it by max offset. So if our normalized velocity is 0, meaning we're not moving, it's going to give us 0 when we multiply it with max offset. If it is at 0.5, so we're moving slowly, like half speed, and we multiply that against max offset, it's going to give us 50. So it's going to move it halfway between the max. So float fixed velocity is going to equal, FMath doesn't have this, Kismet Math Library does. So make sure you include Kismet Math Library. And we want to normalize to range. So it takes in the value and then min the max. So the value is going to be our velocity. The min is going to be 0. And the max is going to be max velocity. And then to be safe, we're going to clamp this. So fixed velocity equals fmath. Clamp. We're going to clamp fixed velocity between 0 and 1, just to make sure it's fine. And now we want to set fixed velocity times equals max offset. Or we can almost separate it into a separate value, but we can use fixed velocity for this. And then we're just going to set our y to equal that fixed velocity. So I'm going to go ahead and close this down and relaunch and show you how this all kind of works together. All right, let's reopen that widget and start tweaking. So here we have our test velocity. Let's drag it up. And as you can see, it is moving our crosshair around. Granted, it's going in the wrong direction, so we're going to make sure we want to make that negative. So I'm going to make sure, go to our position.y and just put a minus sign in front of it. And that'll make it go to the negative value of it. So now, click on it. There we go, just reset. We're at 0, we go negative, it does nothing. But if we go here, we're now getting positive, we start increasing. Starts moving up until we hit our max velocity of 350. And now it no longer goes up anymore beyond that. So we hit our limit there. So 350 is our max. Now if I increase max velocity, it's going to go down because we're only, we're not all the way at our full speed yet. So you can set this to scale with any velocity you want. It's going to scale in the same way. So if different characters have different speeds, you can easily set this up to work with it. So I'm going to do 350 and 350. And if you want to make it so they move more, you just crank up the max offset. So you have, less does more basically with a higher max offset. So 100 actually wasn't that bad. So that's about the max that it would be at. So now we just got to do it for the rest of these. So the left, right, and the bottom. So let's basically just copy and paste. So this will be bottom, left, and right. So bottom, left, and the right. Now we're going to make sure we set these here as well. So size box bottom, size box left, and size box right. And then we just got to do the positions to where they fit. So the bottom is going to be the opposite of the top. So remember when this was a positive, it was going down. So we want to do that for the bottom. Left is going to be, I think, negative on the X. So we're basically just going to invert this. So Y is going to be 0, and the X instead is going to be the fixed velocity. I'll just copy and paste this down here. And then the right should be, I think, the positive. I feel like I'm backwards on this. But let's just see real quick. Okay. No, I'm right. So yeah, we're good. It's moving all of these based upon our speed. So now we can have nice control over it. All right. So we know that that's fine. Now we just got to set up to work with our pawn's velocity. So what we can do is just override native construct. So basically what you see like here, this is native construct, this is native pre-construct, this is native tick. They're a little bit different than your, like in your actor, for example. So we're going to override native construct, and this is basically what's going to fire once we actually, set it up. Like once it's constructed, hence the name. So not when it's not like our actual constructor. This fires, I believe, once the widget itself has been created. So what we can do here is set up a series of functions that'll go through and it'll give us the canvas panel slot of a specific size box that we want. So if we can't get this, for example, when we're running this, we'll just have a function that we can call that'll give it for us. So we'll do that kind of last. So I'm going to go ahead and close down the editor real quick. And in here, I want to start up a timer that is basically going to call handle crosshair sway or handle crosshair scale, basically just on a fixed interval. So get world, timer manager, and we're going to set timer. Now we got to create the handle and that kind of stuff. So let's go ahead and construct the handle or create the handle. So F timer handle. I'm going to call it T crosshair. Then pass in this, and then the function we want to call, which is going to be handle crosshair scale. So the problem is this takes in a parameter. So instead of using this directly, we actually need to create a delegate that will fire it off and pass in a velocity for us. So what I'm going to do to also simplify this is set it up so where we actually have two kind of variations of it. So one that takes in a velocity and another one that just takes in nothing. So what we can do is have void handle crosshair scale. Spell it the same. And this is just so I don't have to bother with the delegates. And here we're just going to call handle crosshair scale and pass in test velocity. So we're going to do basically give it the address of the function. So FPS Template Crosshair Widget handle crosshair scale. And then I believe it's the delay. So this can be our rate. So I'll just give it to 1 for now and pass in true. So the rate that we want it to be, I want to be controllable as well. So we're going to have another value here. We float, and I'm going to call this one update. Let's do update per second. Guess that's an okay name. And by default, we'll leave it at 60. So, and rate is going to be updates per second. So basically, it should fire this function at what we set this at. So we actually need to divide from this. So we're going to do 1 divided by that amount, and that should give us the delay. So 1 divided by updates per second, or 1.0 divided by update per second, should give us a delay of 1 divided by 60, roughly this. Okay, so that should be pretty much everything we need to test it out. Let's go ahead and try it. All right, let's reopen that up. And we should be okay and good to go. I guess I probably should have printed out a log first to make sure that it's firing. But anyways, so we're passing in test velocity. So what we can do for the time being is actually set test velocity to equal our pawn's velocity. So we're going to grab our owning pawn. So if owning pawn, we're going to get the velocity dot size. That should be like a max of like 600 or something like that. Then we're going to set test velocity to equal our pawn's velocity, and that's it. So this should allow us to scale based upon, well, our velocity. As I move forward, you can see it opens up. If I sprint, it opens up even more. If I run, you can see it changes based upon my speed here. And it's a direct change to it. So one thing we could do if we really wanted to would be interpolate to a speed. You can see if I move to the side, move a little slower if I crouch. Oh wait, I don't have crouching set up. That's set up to my inventory stuff, which is also not plugged up. But yeah, we have it set up to that. So let's try and tweak our, update for a second. Let's try like 5. Make sure that that's actually set up. Yeah, so you can see it's updating very slowly now. So that's where we could set it to something like 30, and it should still look smooth. Now I can see some jitter. So yeah, probably want to leave that at 60. I mean, it's relatively lightweight anyways. But anyways, now that we have that portion set up, what we can do now is go ahead and cache all of our canvas panel slots and just work with that directly. So we're basically inside of native construct. We're going to get all of our canvas panel slots and basically just access them directly from the header as needed. So grab this, we're going to forward declare it up here. So forward declare you canvas panel slot, and then down here we're going to start setting these up. So CPS underscore top, CPS underscore bottom, capital that left and right. And then we're going to grab, so we can just grab all of this and move it into native construct and delete the contents that are actually inside of it. Actually, we can remove the if statement. Yeah, we'll just remove the if statements. That's not needed at all. Wasn't thinking too clearly on that. All right. So here we have our top, bottom, left, and our right. And then same thing here. We got to do it with our size box. And there we go. So now instead of casting, we basically just access it directly. So if CPS top, bottom, left, and right. And then I'm going to move the position up. Kind of have its initial, I guess, just use it and reuse it instead of constantly creating a new one. The position, and then we just modify it each time we enter in here, because either way, I mean, it's fine. So we know the position by default is going to be 0 on the X and Y, so we can just set it up like so. Anyways, let's go ahead and relaunch and make sure everything's still good to go. All right, so there we go. Crosshair is still good. It scales with it. Not a huge fan of how jumpy it is, but like it's literally a 1-to-1 ratio with our speed. So what we could do is interpolate it to make it a little bit slower, but either way, I'd say it's fine. One thing we can do is get an else statement here that will assign the canvas panel slot if it cannot find it inside of native construct for whatever reason. So I'm going to go ahead and create that function, and it's going to return a u canvas panel slot. Get canvas panel slot is an appropriate name. It's going to take in a u size box and call it size box. Move that up right below native construct, which I meant to do right here. And basically, it's going to do what we do right here. So we're going to return. So we got to make sure size box is valid first. If so, we return the canvas panel slot. Otherwise, we return a null pointer. So now we can actually just call GetCanvasSlot directly on it. just like so. And that'll kind of clean it up a little bit more as well. And then from here, that'll allow us to, if one of these are valid, so otherwise it's invalid, we want to set CPS top to equal get canvas panel slot sp underscore top. We're basically going to do this for the remainder. So CPS left, CPS right, and bottom, and then the size box, bottom, left, and right. So either way, I'd imagine, like, I highly doubt this would ever fail, but this is just like that one little fallback to really enable it. So if it does, well, there's a way to, it's, it'll resolve itself out as long as nothing's truly broken. But anyways, that's one way that you can set up a pretty efficient and customizable, well, adjustable crosshair. So pretty simple. You gain full control over it through here. And let me guess. Synchronize Properties. Crosshair scale. Oh, yeah, that's right, because I'm not getting it anymore. So that would be why. So what we could do to resolve that, if we wanted to constantly still see the actual update, which I do, I'm going to call Synchronize Properties from native construct. So after I set the canvas panel widget, I'm going to call Synchronize Properties. Actually, I just realized I can't do that. And I don't want to fire off a timer. Let's see here. We can do this directly inside of Synchronize Properties then. So instead of duplicating all the code around, we void set canvas panel slots. And that's going to contain all of this. And I can wrap these, I don't think it's going to matter. So get canvas panel slots. No, set canvas panel slots. Like so. All right, so now it's going to set the canvas panel slots from Synchronize Properties, so that should allow us to get all the information that it needs for handle crosshair scale to function. And ultimately, this should have fixed it either way. I'm kind of surprised that it didn't, but it is what it is, so this should work. There we go. So now we're back to being in control. So we can set this up to where we can have some crazy high max offset. And you basically got full control over the basics of what you would want to use it for. So here's the default. As I'm walking and as I sprint, it goes to pretty much the max speed. As you can see, it's constantly changing based upon my velocity. So I'd say it's good to go. So there's still some things, oops, no, not at 100, that I'm going to want to tweak about this, because this is going to be, I guess, now that I've made it a part of the plugin, I might as well continue with it. But there's not much else to say. I'm going to do a quick run through of what all is going on, and that's going to be it. So what's going on for testing on the fly is every time we make a change, so this is at 689 point something something, if I set this to 0 and press enter, it's going to call this function. So it calls Synchronize Properties. From there, we go ahead and set our canvas panel slots, which you should be familiar with by now, and we adjust our crosshair by just simply calling the function that actually adjusts it for us. So we're basically doing this kind of as if we're using it in the game, because we're treating the editor in this case as the game. So we're pretending that our velocity is like our test velocity. And then we have our handle crosshair scale function. So I do want to add another function in here that'll dictate whether or not we run a timer. So I'm going to make this a boolean. And this one's going to be update from outside source, or updates from outside source. And I'm going to set that to false by default. And then if we do not update from an outside source, then we want to set a timer that will run it for us. So this basically gives our owning pawn, it kind of makes this optional. So if people want to, they can get direct access to this widget and call handle crosshair scale however they want. So in which case, make this blueprint callable and give it the category FPS template, we'll just do crosshair. So now people, if they want to, they can directly call this function and it'll do the exact same thing as what this is doing here. They just got to pass in the velocity that they want. So we can really, yeah, I think that's actually pretty much it. So that sums up basically everything that is, I guess you could say, required. So anyways, so if we do not want to update from the outside source, then we want to go ahead and set a timer that will call the function on our crosshair scale. So it's going to be adjusting it automatically based upon our speed. So you don't need to do anything else. It's just going to work kind of from the box, so to speak. And if you don't want that, then you have to call this if you want to get it to work manually. So you would call this maybe in your move right or your move forward function. So that way it fires whenever your value changes from 0. And then what all is going on inside of it is we have our canvas panel slot. So the canvas panel slot is what allows us to actually move it around. So basically we have our canvas panel. The canvas panel has a series of slots, and those slots are filled with size boxes. Now, because those slots are filled with size boxes, we can't move the size boxes themselves around. If we want to move the size boxes around, we have to move the slot that holds the size boxes. So basically moving the slot around is what we're doing with all this. And yeah, I think that's about the simplest way I can put it. My throat's starting to get scratchy, so I'm going to end it here. I can feel it starting to go out. But anyways, that is going to be all for this video. I hope you learned something, and I have a crap ton more like this on my channel, so check out more, I guess. See ya.